We are on page 102 and problem number 3. Draw another parallelogram below. So I drew a parallelogram below and I put diagonal lines because for problem A, it asks you to draw the diagonals and measure their lengths. Record the measurement to the side of your figure. So the measurements are using a ruler. I'm recording in centimeters because it is more accurate. So I measured this one and it's about 2 centimeters. 2 centimeters. This one is 2 centimeters. And the line over here is 4 centimeters and right here is 4 centimeters. Okay, so your diagram doesn't have to be perfect, but I just want you to see what a parallelogram looks like and what its dimensions should be. If you notice, these two are the same. It's just split in half. 4 centimeters and 4 centimeters is just split in half. So all the dimensions should be the same. Problem B. Measure the length of each of the 4 segments of the diagonals from the vertices to the point of intersection of the diagonals. So the vertices is right here, okay? And the intersection, meaning where 2 lines cross, is the middle. So that is the intersection, and these are the vertices. I'm going to label this so you know that this is a vertice. Okay? Now, number 2, list the properties that are shared by all the parallelograms that you worked with today. So I'm listing properties. Property means that, not property like in a house or land, but in this case in math, it is what distinguishes them apart, okay? So a parallelogram must have 4 sides. You notice there is 1, 2, 3, 4. There are 4 sides. 2 sets of opposite sides are parallel. So parallel meaning that they have sides that are the same. So if you notice, this line is parallel to this line, and these lines are parallel to this line right across from it. So it has 2 sets of opposite sides that are parallel. Number 3, their opposite sides are equal. If you notice, this is 4 centimeters, so is this one, 4 centimeters. This one is 2 centimeters, so is this one, 2 centimeters. Now 4, diagonals. Diagonals bisect each other. Diagonal meaning like their sides cross. You see this? They both cross with one another. Now, problem 4, or A. When can quadrilaterals be called parallelograms? So a quadrilateral usually has 4 sides, just like a parallelogram. And that's a good question to ask because they are very similar to each other, right? A quadrilateral can be called a parallelogram when a quadrilateral has 2 sets of opposite sides that are parallel. So they need to be parallel in order for it to be called a parallelogram. Okay? Now, B. When can a trapezoid also be called a parallelogram? Now, a trapezoid, you guys learned about trapezoids yesterday. They commonly look like this, right? Well, they must have 2 sides or 2 sets of opposite sides that are parallel. So this one wouldn't be considered a parallelogram because this side and this side are not parallel to each other. However, if it was leaned like this, then yes. Or if your trapezoid is a different picture, or looks differently and has all parallel lines, then it would be considered a parallelogram. Okay? I'm going to turn the page and we are going to be on page 103. If you notice right here for page 103, number 1 says angle A measures 60 degrees. So they're giving me something already. They're giving me a measurement of one angle. And where is angle A? This is angle A right here. And it measures 60 degrees. So I'm going to write 60 degrees right there. Now for problem A, it asks you to extend the rays of angle A and draw a parallelogram A, B, C, D on the grid paper. Ms. Tran, what does that mean? What does it mean to extend? Extend means that you're going to continue drawing it out. And you're going to create your very own parallelogram with the grid lines that they give you here. And now they want you to label it, the parallelogram, A, B, C, and D. So A, B, C, D. That's how I'm labeling it on the grid paper. So I did problem A. Now B. What are the measures of angle B, C, and D? Okay, so I need to figure out, okay, what are the other measurements of my angles? Remember I said that for angle A, opposite sides are going to be equivalent. So the opposite side of angle A is going to be angle C. So angle C is also 60 degrees. So I'm going to write right here 60 degrees. Now, Ms. Tran, how will I know how many degrees is angle B and angle D if that's not given? Well, remember I told you that the lines are 180 degrees. So angle B is going to be 180 degrees minus angle A or angle C, 60 degrees. So 180 degrees minus 60 degrees. What is that going to give you? Okay, so I would subtract on the side so you guys can see. 0 minus 0 is 0. 8 minus 6 is equal to 2, and bring down my 1. So now I know that angle B is equal to 120 degrees. And that's what I'm going to write right here. And now, how about angle D? Same thing with angle D. For angle D, you need to subtract 180 degrees minus 60 degrees in order to get 120 degrees. So this right here is also 120 degrees for angle D. Now, a really cool trick you can use to figure out if your shape is correct and your angles are correct is if you add all four sides. So when I add 60 degrees, which is angle A, plus 120 degrees, plus 60 degrees, plus 120 degrees, I'm going to get 360 degrees because the shape is always going to equal to 360 degrees. Okay? Now, I'm going to move on to problem A for problem 2. WXYZ, which is this shape right here, is a parallelogram not drawn to scale. So it's basically telling you it's not exactly this small, right? A. Using what you know about parallelograms, give the measure of sides X, Y, and Y, Z. So we have X, Y right here, okay? I shaded it in orange so you can kind of see that. So X, Y. I'm looking at X, Y. And I'm wondering like, well, what could it be? There's no measurement right here. Remember, parallelograms, opposite sides are equivalent. So if this is 6 centimeters, this is also 6 centimeters. If this side is 3 centimeters, then this side is also 3 centimeters. It's very similar to a rectangular prism, right? All the sides are, the opposite are the same. So 6 centimeters for XY. And then for YZ, notice I colored YZ in blue, is 3 centimeters. So I'm going to write 3 centimeters. Now for problem B. It says right here, WXY is equal to 113 degrees. Use what you know about angles in parallelogram to find the measure of the other angles. So we know that WXY. Now this is a little different. I haven't really taught you guys this, so I want you to really pay attention. So I'm looking at angle WXY. This middle letter right here is going to tell you which angle you're going to measure. So angle X is going to be 113 degrees. So angle X is equal to, I'm going to put it like this. And I'm going to write 113 degrees, okay? Right in there. So that's angle X. Now, they want me to use what I know about parallelograms to figure out the rest of them. So looking at this one right here, remember I told you opposite sides are the same. So if this angle is 60 degrees for angle A, the angle C must be 60 degrees. So looking at this measurement, I have 113 degrees. So the opposite side must be 113 degrees. Okay? Now, that means that to figure out Y and W, I need to subtract. So I'm going to subtract 180 degrees minus 113 degrees. Okay? 10 minus 3 is equal to 7. 8 minus, not 8. 7 minus 1 is equal to 6. So this side is 67 degrees and this side is 67 degrees. Okay? Knowing that, I'm going to look at these numbers here. Now, a trick I like to use is I know that the middle one is always the angle. So this one says angle XYZ. Angle XYZ. So angle Y is going to be 67 degrees. Next one, YZW. Looking YZW. The middle one is the angle. So it's at 113 degrees. Next one, I have angle ZWX. So I have right here ZWX. So the middle letter is W. That's the angle I'm looking for, 67 degrees. Okay, now I'm going to move on to problem 3. I need to move my ruler. Problem 3, it says right here, Jack measured some segments in problem 2. He found that WY, so they're giving me one measurement already, WY. So the line up here means the side of WY. So I'm going to measure the side of WY. So this is the line I have right here, WY. Okay, so this whole line is equal to 8 centimeters. So that means that each side is 4 centimeters. Okay, now the other line I have right here is MZ is equal to 3 centimeters. So this whole line is 3 centimeters. So that means that this is 1.5 and this one is 1.5. Or you can say 3 centimeters and you can put it in the middle. So the first one they ask you to figure out is WM. So looking at WM is this measurement right here, WM. So WM is only 4 centimeters. Next we have MY. MY, same thing, 4 centimeters. Next we have XM. So side XM. We have XM. And I told you earlier that XM is equal to, oh, I did something wrong. My bad. So right here only said MZ. It didn't say XZ. Silly Miss Tran. So MZ is 3 centimeters. And this side is also 3 centimeters because they are the same. So measurement XM is equal to 3 centimeters and XZ is equal to 6 because 3 plus 3 is equal to 6 centimeters. Okay, now I am going to turn the page. And I drew this diagram so that you guys can see it better. I think it would be a good idea to draw it out. We're on page 104. And for page 104, they kind of want to give you an explanation of how to solve for things. So number 4 says right here, using the properties of shapes, explain why all parallelograms are trapezoids. So I'm explaining here by using sentences. All parallelograms must have 2 pairs of parallel lines. That's true. Trapezoids must have at least 1 pair of parallel sides. This means all parallelograms are also trapezoids. Okay? Now, 5. Teresa says that because the diagonals of a parallelogram bisect each other, if one diagonal is 4.2 centimeters, the other diagonal must be half that length. Use words and pictures to explain Teresa's error. An example to show that Teresa is wrong is a rhombus. Rhombus is a diamond, right? That is also a square. See image to the right. This is a parallelogram in which the diagonals are the same length rather than one being half the length of the other. So they have the same length. And that is all for today for page 104, you guys.